In this video, we are going to study about least common multiple and greatest common factor. Operations for least common factor and least common multiple and greatest common factor is similar. We are going to do prime factorization, like we are doing prime factorization, but this time we are going to group the terms and we are going to do the prime factorization. And it's better to explain everything on the exercise, so I'm starting the example for 28. Here, when you do the prime factorization, if you remember, you were writing the numbers, then you were drawing the line, and you were starting to divide them by prime numbers. Now, I'm going to divide both of the number by the smallest prime, 2, if it is possible. If it is not possible, which one is divisible by 2? I'm going to continue with that one. Okay, then both of them divisible by 2, so the result when you divide by 2 it's going to be 9, and when you divide by 2 result it's going to be equal to 15, and the results are written down of the number. And here both of the number is not divisible by 2 now, and both of them they are divisible by 3. That's why I'm going to divide the numbers by 3, and the result is going to be equal to here 3. When you divide by 3 it's going to be 3. When you divide by 5, when you divide by 3, the result is going to be equal to 5. This part is very important because now both of the number is not divisible by the same prime. Because 3 is divisible by 3, but 5 is not. So what we are going to do for these cases? We are going to divide with the smallest prime now, which is 3, and this number is going to stay same. So when you divide by 3, this is going to be 1, and we are going to leave this number as 5. And for 18, we are going to finish the operation. We are going to continue with 5. Now, 1 is not divisible, that's why we are not caring about 1, and the operation for this row, it's finished. For this column, it's finished, sorry. And we are going to continue only with this column now. And here, the number is 5, so 5 only divides the 5, and the result is going to be equal to 1, and this was already 1, that's why we are not dividing and we are not continuing. Actually, we are not doing an operation there, but this part, as I told you, it was important, and the result is going to be equal to 18, and for least common multiple for 18 and 30, this is the way of writing, is 2 times 3 times 3 times 5, which is equal to 2 times 3 is 6, times 3 times 5 is equal to 15. 6 times 15 is going to be equal to 90, and 90 is dividing both. 18 and 30 is smallest common multiple of 18 and 30 is going to be. Here, this exercise is going to be classwork for us, and I'm going to do the same operation for the greatest common factor. Here, greatest common factor is, of course, as you understand from the name, we are going to deal about the factors, and we are going to deal about the common factors. I'm going to write the numbers 40 and 60, then I'm going to do prime factorization, and I'm going to divide the numbers by the prime numbers again, 2, 3, 5, 7, and so on. And here, the smallest prime number, as usually we understood, it's 2. And it's going to divide both of them. And if it is dividing both of them, we are going to circle that one, because this is going to be the common factor for us. And the second number, the result, it's going to be equal to, the result when you divide 40 by 2, it's going to be 20. Under 40 I'm writing, and when you divide by 2, it's going to be equal to 30, and under 60 I have written. Now I'm going to divide, I may divide by 2 again, and this is also common for us, and that's why I'm going to circle it, and it's going to be equal to 10 and 15, and we are going to finish here. Here only one number is divisible by 2, that's 10. So 15 is not divisible, it's going to stay same. It's going to be 15 again. We are going to get it down. Same number, 15. When you divide 10 by 2, it's going to be equal to 5. And if we continue with the smallest prime, 15 is divisible by 3. That's why I'm going to divide by 3. But this 3 is not dividing both of them, and it's going to be equal to 5 and 5. Because 5 is not divisible, it stays same, and you are going to write it down. 15 is divisible by 3, the result is 5. And when we finish this part, the last prime is 5. 5 is dividing both of the 5, that's why the results are going to be equal to 1 and 1. And since it is common, I'm going to circle it. And when I write the greatest common factor, I'm going to take only the circled numbers, which means greatest common factor of 40 and 60 is going to be equal to 2 times 2 times 5, which is equal to 20. And 20 is dividing, as you see, 20 is dividing both 40 and 60. And the greatest common factor, GCF 40/60, it's going to be equal to 20. As you see, this operation, it's same with the least common multiple, only we are going to circle the common factors, and we are going to find the greatest common factor with this method. And without solving this question, I can write here also least common multiple, because everything is same, only we are going to take all the numbers. So LCM of 40 and 60, it's going to be equal to 2 times 2 times 3. It's better to write a bit left. 2 times 2 times 2 times 3 times 5, which is equal to 8 times 3 times 5, which is equal to here 120. So least common multiple of the 40 and 60 is 120. Greatest common factor of 40 and 60 is going to be 20. As you see, the operations are same. That's why I didn't write another question for finding least common multiple. Here, this is the third definition about GCF and LCM. These numbers are relatively prime numbers when their common factor only 1, which means these numbers are divisible by another number. 14 is not prime number. 27 is not prime number. But when we check the prime numbers, we cannot find any same prime. If I try to divide by 2, only 14 is divisible. So this is going to be 7. And this is 27 again. And 7 and 27 is not divisible by 2. The next prime number is 3. And when you divide by 3, this is going to be 9. When you divide by 3, this is 7, this is 3. When you divide by 3, this is 7 and this is 1. And on this column, we finished the operation. I'm going to continue only with this column. When you divide by 7, the result is 1. We complete the operation. And as you see, I couldn't circle any of the prime number here because it's not dividing any number. So we are going to say like this: greatest GCF of 14 and 27 is equal to 1 only, which divides both of them. None of the prime number, they don't have common prime number. That's why they are called relatively prime. They are relatively prime, which means they don't have any common factor.